Enrico is our Cleve Moeller and MathWorks Chair in Mathematical and Engineering Software Distinguished Lecturer. So, so this is funded by this endowed chair from, excuse me, the developer of MATLAB. MATLAB, in case you didn't know, was developed right here at UNM and generated some revenue, which is giving us the ability to hire an endowed chair and also to bring in some distinguished speakers like Enrico. He is also my partner in, there's no crime, but my partner, there's a little bit of crime, in the New Mexico AI Consortium, where we're really trying to bring together all of the New Mexico universities, CNM, Los Alamos, Sandia, in order to increase our footprint. There's, as we've been talking about, there's so much going on in AI. When we can pool our resources and work together, we think we will be a real force in shaping this AI future. And so Enrico is going to tell us about some of the things they're doing down south and look for ways that you might find collaborators in other parts of the state. And I'll turn it over to Enrico.
Thank you so much. Well, first of all, thank you so much for inviting me. It's an honor to be here. Now I feel the pressure with all the titles that are behind me. So I hope I'm not going to disappoint. Of course, I'm a dean, which means I cannot talk about anything technical. That's forbidden by the title of the dean. So what I'm going to try to do is to just give an overview about what is going on in terms of AI at New Mexico State University. My hope is that actually something is going to catch your attention and you'll say, yes, I want to work with that person. Because we love collaborations, and we love in particular collaboration with UNM, because you have a lot of very good people here. So please be on the lookout. It was very interesting in the opening presentations. There was actually some conversation about the legacy of AI at UNM. So I want to do the same. I want to actually talk a little bit about the legacy of AI at New Mexico State University, because actually we have a long, long history of AI research at NMSU. In particular, back in 1983, the legislatures of New Mexico invested in the creation of a certain number of centers of excellence. And one of them was called the Computing Research Laboratory. And that was funded at New Mexico State University. It was part of what was called the Rio Grande Corridor, which was creating a number of centers of excellence across the Rio Grande line. It was founded in 1983. It grew very quickly. There were 14 faculty members, part of that center, 38 full-time researchers, 30 graduate researchers, 5 staff members. And for a while, that Computing Research Laboratory was the center of AI research in certain areas of AI for the entire nation. A lot of investments in natural language processing, automatic translation, computer vision. Some of the foundation of connectionism actually came out from that lab. So there was a lot of cool research going on. And that computer research lab lasted for until around 94, 95, and then sort of faded away under some bad leaderships in the lab. But I remember when I was in the department, I joined the department in 92, and the Department of Computer Science hated that CRL because they were able to hire all the good graduate students. I mean, they had 30 graduate students at any point in time hired by the lab. So back in 83, there was a lot of AI research going on. And I think over the years, we kept that going. Of course, with CRL closing down, a lot of the researchers moved in the Department of Computer Science. So we constantly had a good core of AI researchers, and we tried to keep them. I tried to put some names here, and I tried to separate people into two groups. One is people that are doing what I refer to as foundational AI research. So these are all computer scientists, as you can imagine. I put myself there, I shouldn't be there, but we have a lot of people, of course, doing machine learning or different aspects of machine learning, as everybody else do. But we have a long history of research in symbolic AI, logic-based method. And that has been, for many, many years, our strength, and continues to be our strength. And of course, now we're trying to explore how can we combine that with machine learning, so that we can actually introduce reasoning capabilities into our machine learning systems. But what I think is really interesting of NMSU is actually this. The fact that we have a lot of people that are using AI and applying AI to solve problems. And to me, that's very interesting because each one of those applications creates more work for people that are doing foundational AI, because they discover things that are not there, that are missing. And that, of course, gives us new ideas and new research that we can perform. And one thing that I think is really interesting is the fact that these people are spread across the entire university. We have them pretty much in every college, and they're doing work in areas. Of course, you would expect engineers to be doing AI, but we have a lot of people in agriculture doing AI. We have people in sociology that are doing AI. So they're really across the entire university. And in fact, we didn't even fit in one slide. So, and even some of our computer science people are really doing applied AI. That's really what they're doing. So Shiva, for example, is our one of our latest hires. She just joined last semester, and she started using AI to study migration, people migration, and issues with immigration and illegal immigration. So it's very, very interesting work. So I wanted to just spend some time to give some sample research efforts that are going on at NMSU in the area of AI. Once again, these are just examples. It's not exhaustive in any way. And once again, if you find something that piques your attention, please let me know, and I would like to connect you. So let me actually start by looking at some of the work in foundational AI. And of course, selfishly, I have to start with one of the areas that I'm working in. I'm just trying to. So for many years, we've been working on knowledge representation and reasoning. How do we model agents, and how do we model the capabilities of agents in terms of actions that agents can perform, and of course leading to things like automated planning and automated diagnosis and so on and so forth. And over the last few years, we have shifted from single agents to multi-agents, which is very interesting. But we also want to have multi-agent systems where autonomous artificial agents are immersed in a domain where there are also humans. And we want these agents to be able to either work with the humans or manipulate the humans. So we have to deal with things like epistemic reasoning. How do we actually deal with reason about beliefs of people? How do we reason with the knowledge of people? And how can we perform actions that are going to manipulate or take advantage of that? So we are dealing with epistemic reasoning in multi-agent systems. It's complicated. Now, of course, there is an extensive literature on this topic. A lot of that work has been done in the context of logic. So there are a lot of different logics that have been developed to capture these things. What comes out is that you cannot, those logics are beautiful, they are very elegant, they are not practical. So if you really want to build, for example, a planner for a multi-agent systems that does epistemic reasoning, you cannot use those logics because they are not scalable, they are not efficient, they are intractable. So we were trying to actually look at something a little bit more pragmatic, which means can we design actually high-level declarative description languages that allow us to describe these type of agents that are operating in these type of scenarios? And how do we actually develop efficient, and here I have to quote efficient because we are still dealing with a lot of computational tractability issues, and then how do we actually apply it into different types of domains? So in terms of summarizing some of the accomplishments that we have achieved in this area, we have designed several action languages, which means declarative languages to describe agents and capabilities of agents. We investigated different types of actions that agents can perform. Ontic actions, which means actions that manipulate the world, like opening the door, closing the door, turning on the light, as well as epistemic actions, which means actions that instead deals with either the knowledge or the beliefs of the agents. So for example, a communication statement is an epistemic action because it transfers a piece of knowledge from one agent to another agent. Or for example, sensing. I don't know if the light is on or off. So I want to change my knowledge about that by looking whether the light is on or off. And in particular, one thing that we encounter very quickly is the fact that if we want to actually introduce this type of reasoning, this type of actions in the context of multi-agent systems, we also have to deal with the visibility of those actions. So we may have actually agents that are fully observant, which means they are absolutely aware about the actions being performed, either by themselves or by somebody else, and they also know what is the outcome of that action. So for example, I'm here, I see you turning on the light, and I also see what is the result of you turning on the light. But then there may be also agents that are just partially observant. Like for example, I'm away, I'm outside, I know that you're turning on the light, but the door is closed, so I really don't know what is the outcome, whether the light was on and now it's off, or vice versa. Or you may have agents that are absolutely oblivious about what is happening, which means that their knowledge, their belief is not going to change, even though something is happening in the world. And so we actually created these action languages that contain these different types of actions. The next step, you have to give us semantics to this language, and that's where things get very interesting. So we actually explore different mechanisms to assign semantics to these actions and how this meaning change as the actions are performed. And in particular, we actually explore two different types of semantic approaches. One is based on cryptic structures, which is something that comes from the world of logic. The other one is what we call the possibilities, which actually is something that comes from non-well-founded set theory. Interesting enough, actually, set theory comes to be useful in this kind of context. We have done decidability studies. We have shown that unless you put certain conditions on the knowledge of the agents, then things they're not very easy to deal with. We are trying to actually also deal with very interesting scenarios, like, for example, what happens if an agent has incorrect beliefs, which may actually lead to very bad results, or, for example, whether we want to actually mislead agents. So how do I actually create an agent that is going to change the knowledge, the belief of somebody else in the wrong direction? So, for example, we want to have fake news type of things. And we had to build some actual planners that actually try to solve some problems. Scalability is still a big challenge. But we actually also learned that heuristics is going to play a very key role if we actually want to create real effective planners. So, for example, for those of you that are familiar with planning systems, you may have heard about GraphPlan, which is one of the most commonly used heuristics to actually do automated planning. We were able to actually develop a version of GraphPlan for epistemic reasoning, and the scalability actually using it instead of not using it is unbelievable. Which means there is a lot of potential there to actually develop heuristics that deals with these type of domains and make them practical, at least for some type of applications. So a lot of interesting things and a lot of interesting problems. Some other examples of ongoing research projects. My colleague Whipping is our lead machine learning data analytics person in the department. She has been doing a lot of work in trying to improve performance of machine learning systems. And performance both in terms of efficiency as well as correctness. So produce more accurate results. And in particular, most recently, she has actually tried to develop mechanisms for systematically evaluating machine learning models in terms of identifying kind of when they are producing hallucinations and when they are actually used for misinformation. So some of the work that she has been doing, and I'm actually just quoting, I know that for many years she has actually been working on machine learning applied to time series for time series analysis, as well as machine learning applied to graph structures. And she has been actually doing a lot of interesting work. Recently, she has actually started looking at how to integrate machine learning with symbolic knowledge. So trying to cross that boundaries between statistical and symbolic reasoning. And she has been actually very active in application of machine learning in different types of domains. In particular, most recently, she has been working on applications with livestock management, which is kind of an interesting domain. Tuan is another one of our recent hires. He came to us with a lot of experience in natural language processing. And what he has been doing recently is looking at how to apply natural language processing techniques and generative AI techniques to actually study scientific text. The number of scientific publications is exploding. And keeping up with the state of the art in the field is becoming more and more difficult. So what he has actually been developing is text summarization techniques, mechanisms to actually compare scientific documents and try to determine whether they're producing similar results, as well as visualization techniques in order to visualize the content of scientific documents. And he has produced a lot of very interesting results. I'm going to bring myself back in. I've also been doing a lot of work in constraint solving and constraint optimization. Constraint programming, basically you have a set of variables that represent, for example, features. You have some domains for these variables, which are the range of values that the variables can assume. And then you have some constraints, which are what are the acceptable assignment of values to the variables that you can deal with. And if you are doing optimization, then of course you also have an objective function that you're going to try to optimize. A lot of common applications, scheduling, assignments, and things like this. And we've been working on two different thrusts in this area. One is actually how we can take advantage of things like GPUs to actually speed up the resolution of constraints. And in particular, we're looking at complex constraints. So constraints that use a lot of different variables, and they're trying to do some interesting propagation behind that. And we have some very interesting results. There are some global constraints that actually are very amenable to be parallelized on GPUs, speeding up the resolution. And then we've also been working on distributed constraint optimization problems, which means we have constraint optimization problems, but on top of that, we have a number of agents, and every agent owns a certain set of variables, and they can only communicate with other agents where the variables are in common within a constraint. And that kind of is very useful to model situations where we have, again, multi-agent systems, and there are issues of privacy, so not everything is known to everybody, and you still want to find, for example, optimal solution. And we have actually developed a number of new algorithms to solve this type of problems. Now let me actually give you some examples about research efforts, things that look at applied uses of AI. So first of all, actually, I tried to kind of come up with a word cloud that kind of summarize what I've seen from everything that I've received from my colleagues at NMSU. So some names, some words come up very clear. So climate. So we have a lot of people working on issues of AI related to climate. Water, that's not surprising. We have a very extensive research efforts at NMSU in terms of water management, reduced water, and other things like these. Security and power are other two terms that come out very, very often. And so we have a lot of research effort in those areas. So let me give you some examples. So this example came from our friends in electrical and computer engineering. We have a very large group that works with deals with issues of power systems, in particular grids and smart grids. So this actually is one of our recent hires, Dr. Shi. And what Dr. Shi is looking is use of AI to actually improve resilience and efficiencies of electric grids, and in particular looking at smart grids. So right now, if you think about a grid, right, think about electricity. You go home, you turn on the light. What do you expect? You expect the light to be on. Now, in order to actually, in the old school world, in order to meet that demand, the generation has to be always kind of excessive. Because when you go home and you turn on the light, you want the light to be on. You don't want actually the power systems to be not able to meet your demand. Which of course typically means that there is a lot of overproduction. So AI system may actually help forecasting needs and try to actually improve performance. Not only, but also we have a lot of more extensive uses of renewable energy sources, solar panels, windmills, and other type of alternative sources, which are very difficult to integrate into the grid because they are less predictable. So AI can actually help us in trying to predict the needs, predict the demand, and actually also improve scheduling. For example, I don't care if my dishwasher starts at midnight, because as long as my dishes are clean by the morning, I can accept it. So improve scheduling so that we can actually improve performance is something that is very important. There is also the issue of resilience. So for example, if there is a blackout, there can be parts of your grid that can be isolated to avoid kind of a cascading effect. So how do we actually decide and predict when certain things can be cut out and protect maybe some more sensitive areas? So Dr. Shi has actually been working on different applications of AI to actually facilitate real-time decisions, both in terms of forecasting the needs, dispatching energy, and control the structure of your grid. Hatim comes from our annual range science. He's an hydrologist, and he has been actually using AI to actually forecast the performance of hydrological systems. And in particular, one thing that is very interesting is on the anthropogenic aspects of hydrology, which means what is the impact of people, impact of population, or impact of presence of animals on the water supplies, and how that can be used. Of course, the ultimate goal is to predict availability of water and predict actually things like when to irrigate and when maybe it's not a good time to irrigate because that can create problems. Her team has a lot of different efforts that are related to application of AI in the terms of water management, and he's doing some really amazing work. These actually come from our environmental and plant sciences. Lot of different applications of machine learning. I'm going to mention just some of them. So this actually is Neil. He's actually a researcher who has been primarily working on arid and semi-arid lands. New Mexico is arid lands, is considered arid. Arid lands cover currently about 40% of the surface of the world and is expanding, which means understanding the functioning of arid lands is going to become more and more important, both in terms of plants as well as in terms of animals. And if you think about, for example, New Mexico, a lot of our livestock is actually grazing in very large areas, which are very difficult to, for example, oversee. So things like how do we collect data from satellites or from drones to actually track the movement of our livestock? How do we actually guide the livestock to the right sources of water? Or how do we prevent the livestock to actually continually grazing on a certain area, which is going to permanently damage that area instead of actually move them to more promising things? So a lot of different applications of AI are available in this. One of the projects that is not written on this, we're actually trying to use virtual fencing to guide the livestock where we want them to be. And we use machine learning to predict where water availability is so that we can guide the livestock automatically on these areas. So it's a lot of very interesting aspects. Another application that I've been working on is to actually use drones to take pictures of different type of plants in order to detect automatically whether there are some pests that are actually affecting those plants. Once again, the reality is that there are fewer and fewer human beings that want to be involved in farming. So there is a need to actually make these as automated as possible and kind of remove the needs of pests. Raja is another of our recent hires. He's in industrial engineering. Is very interesting in manufacturing, and in particular in using AI to detect defects into the products of manufacturing. And he's using actually digital twins to do that. So he's using AI to actually improve the creation of digital twins of products in order to facilitate the detection of defects in the production systems of these products. So a lot of very interesting work in this. Okay, as I go towards the end, I want to actually talk a little bit though about AI and education, because that's something that is actually very important to me. Of course, at NMSU, as probably also UNM and many other universities, we're trying to develop new degree programs that deals with AI, new concentration. We have a Bachelor of Science in AI that is going through the approval process. But the problem is that once we get to higher education, it's already too late. And my interest is in actually how to actually bring AI education into K-12 systems. So I'm lucky actually to have some amazing colleagues that are working with me on this type of issues. Some of you may know Irene Lee. She was for many, many years at the Santa Fe Institute. She went to MIT, and now she's back in New Mexico. And we were able to grab her, and now she's actually a research faculty at New Mexico State University. And she's actually really the driving force behind a lot of the efforts that we have been working on. So one of the things I want to talk about is a program that is called Everyday AI. So that's a program that Irene originally developed at MIT. But one of the things that she realized is that this program actually may be much more effective in places like New Mexico, where we have a lot of rural communities and we have an incredible need of providing training that actually make sure that our students are not left behind as kind of AI is needed. The focus of Everyday AI is on building AI literacy. And by AI literacy is basically what is the basic knowledge that we need to give to people to be educated consumers and citizens in presence of AI. So understand what are the basic understanding of what is AI, how it functions, and how can I use it to improve myself. How can I use it in a correct way, in an ethical way for doing this. So Everyday AI really builds on, was created into three phases. So the first phase was the creation of a curriculum that could be used into the K-12 systems. And that's what is called the daily curriculum. So it's basically, and I'm going to say a few words about that in a moment, but it's really giving those basic concepts on what is AI, how can I use AI, and how can I use it properly in particular. Daily curriculum gave rise to Everyday AI, which is a professional development program for teachers. We need to empower teachers to be able to develop content into their classrooms so that their students can actually learn about how to use AI effectively. And then that developed into the final phase, which is Everyday AI Rural. And that's the version of Everyday AI that we are deploying in New Mexico. And that's what we have been doing for the last 2 years. And the response that we have been receiving from teachers has been overwhelmingly positive. So people want to learn that. So, oops. Okay, sorry, I'm missing some slides. Just a second, some technical problems. Okay, so that's what daily looks like. So daily is organized around 4 areas. The first area focuses on ethics and AI. So how do we, of course, what is AI, but how do you actually understand the impacts of AI, and how do you properly use AI? Not for cheating, but actually to improve your learning. So, there are things about understanding biases, understanding what are unanticipated consequences of the use of AI. Also a little bit about what is the environmental impact of AI. ChatGPT has a significant impact on our environment. Some concepts of AI, just basically to understand them enough so that you can understand why things may actually go wrong. So, a little bit about decision tree, a little bit about supervised learning, neural networks, and classification versus generative AI. And all this is done at a level that somebody in middle school can understand it. So, for example, neural networks are taught by actually playing a game where the kids themselves are the nodes of a neural network. And it's really fun, it's a lot of exciting. A second part here deals with generative AI, trying to understand what is good and what is bad, what is an hallucination, and why you may get some bad things, and also understanding what is a deep fake and what is the spread of misinformation. And then also a component about what are the careers that are associated with AI. We want people to understand that the workforce is going to change, and AI skills are actually important in the context of the future of the workforce. And this actually is the structure of the professional development program. It's an extensive program that lasts an entire year. Initially, we start by training a certain number of facilitators. Facilitators are typically teachers who have already gone through the program, and they are going to themselves teach other teachers. After that, we do have a book club. That's actually a weekly meeting with a group of teachers. It's done typically online, virtually. It lasts for about an hour and a half every week. And basically, we just read a chapter of a book. We take the Mitchell book on AI as kind of our source of information, and we just discuss it in order to make sure that they get one concept, and they start thinking how they could use that concept in the context of their own classroom. Then there is a summer camp where we actually get teachers to develop one module that exposes AI in their content, and they actually test it with a group of students as part of a summer camp, just to see what would be the implication of actually teaching that particular module. And then finally, during the academic year, they actually use that in their own classroom. We have run already 2 cycles of this entire program. The first cycle, we were hoping to have maybe 10 to 15 teachers. We had actually 38 teachers that signed up, and we were able to keep all of them from the beginning to the end. The second cycle, we had 25 teachers that signed up. So there is a hunger for this type of programs and this type of learning. And that's everything I have, so I'm open for any type of questions. And I hope that at least some of these names may actually resonate for you, so that I would love to connect you with any of these researchers. Thank you. Any questions? Yes?
Can you talk some more about how logic-based AI is being integrated and for forms of AI like machine learning
If I knew it, I would tell you, and I would have already published a lot of papers on it. So we are actually still trying to learn. So some of the things that some of my colleagues are looking at is actually how to use. So I talked about autonomous agents. So we have agents. We use knowledge representation mechanisms where we define what are the capabilities of an agent. But there's always been a mystery where that comes from. So we use we use machine learning, particularly generative AI, to actually create the action descriptions for the agents. So that's kind of machine learning feeding into the reasoning process. The other way around is the complicated one, and that's the interesting one. We're still working on that.
No results so far.
Not so far.
Yes. Yeah, I probably have a very detailed question about the formal model of the multi-agents.
Yes.
So you mentioned the cryptic structures together
Yes.
with possibilities.
Possibilities. Yes.
So is that probabilities?
No. So possibility is nothing else than non-funded set theory.
Oh, I see.
Non-well-funded set
Oh,
theory.
see. Okay,
So
I see.
basically sets that can belong to themselves.
Okay,
So
I
you
see,
can
I
add
see.
essentially stuff.
So what's the actual formal model you use to model your multi-agents?
Sorry, what?
Well, what's the actual formal model you use to describe your multi-agents?
It's basically what we have done. So what we have done, we have defined a declarative language that is used to describe what actions the agents can perform
I see, I see.
and what is the effect of the actions.
Okay.
And that is modeled then in terms of transformation of cryptic structure.
I
So
see.
every action takes a cryptic structure as an input and produces a cryptic structure as effect, or a set of
Oh, I see,
cryptic structure,
I
because
see.
most actions are non.
Do you also consider unit time dynamics?
No, we're not doing that. This is discrete time.
Okay, interesting. Thank you.
Sure. Any other questions? Yes.
A question brings you back to your one before the last slide, please. On the education side of your daily lecture, this model.
This one?
Yes, please. That's such a great model with a lot of details to learn from. How about the requirement, like preparation for creating more AI kind of engines or models? This is how to use, how to deal with AI.
This is just how to use. But I mean, think about has been designed for middle school teachers. So the goal is to actually have middle school teachers be able to tell to the student, this is what AI is. This is how you can use it properly. That's why a lot of emphasis on that. It's not for creating.
Yes. So that is more problem, more question. We know that to a good extent we need a good math background to
Yeah.
be able to. So how about the typical encouragement on that side?
So in college, it's a different business, of course, because in college we want them to not just learn to use, but
I'm sorry, encouragement. Like,
encouragement.
Yes, paying attention to the requirements. Of it.
So encouragement to participate in something like this.
But adding some elements to such model to also encourage learning math
Yeah.
in terms of
Okay.
AI requirements.
Yeah. We haven't really talked about the connection between these and that. Because, by the way, the teachers that we have recruited and they wanted to participate in this program, most of them are actually not technical teachers. So we have a lot of teachers like, for example, English, history, theater even. So that's why we didn't try to make it formal to the point where you need to have a mathematical background, because we want it to be as accessible as possible. We hope that, especially when we get to the last part where we talk about careers, there is an encouragement to consider what is the step you need to get into a career, which means also take the right math classes in order to do that. But we haven't pushed very hard on that.
Okay. In such case comes the second half of the question, that is there a connection to other entities or effort to do that? If you don't.
From there to encourage, for example, math.
Basically,
Not-
try to create the capability for creating that.
Yeah, I think there is a potential I'm not aware about existing efforts.
Excellent. All right, well, let's give a round of applause.